So we were talking about the branch level security, right? So where can we find the branch level security? If you go to DevOps portal, so this is also important for a DevOps engineer because we are the one who will actually control the access part with respect to the repository level. Okay, so this is our project. Under this project, under the repos, if you go to branches, so here you will get the list of branches. Assume I want to check the here. If you see here, 3 dots are there, more options. Here, branch security is there. Okay. So if yesterday I was talking about one more option, right? If you see branch level, right, there is an option to lock. So for that, here we have an option. Remove others locks, right? Using this also you can control it. Whether if someone has locked it, then you can, by using this option also, you can manage the locking. Okay. Now, if you take the project collection administrator, he is able to manage permissions. To select the project here, not set, or maybe build administrators, right? You can set or deny permission, either you can allow or deny. So, but basically this particular role, what and all operations each user who is part of these particular groups can perform, right? So where can we add these groups and where can we control? From where are we getting? But we never added these, right? So if you go to project settings here, this is my project settings. Here you will find something called repositories here. Here you will find security. So basically for the branch level, it is inheriting. See here, inheritance. Okay. It is inheriting from the here, repo level. Okay. So this is how it will inherit from the. So this is again for the project level, we are getting all this security related information from somewhere else. So where are we? Where is that origin of this basically, right? If you go to permissions here, under the permissions, there are so many groups. Again, we have not added any group at the project level. Correct? Did we add any group here? So again, this is inheriting from parent. Okay. So in case if you want to add a new group, you can add new group. Okay.
So you say by default we'll get a set of groups.
These are the predefined groups basically, right? Along with the
every project, do we have all these groups?
Yes, yes. This is again coming from the repository level. I'll come back to that maybe in later sessions. So from where actually it is coming from. So there is one separate topic, permissions. I will talk in detail at that time. Okay. Here basically you can add groups, right? You can select any group basically, readers or build administrators here, who are the members here. You can add in case if you want someone, right? Member of this particular is member of project valid users and settings. In case if you want to do something, you can do it. If you see here, whether you can set or do it. Okay. But similarly, if you go to now, just now what we have seen at the project level, similarly, you have organization settings, right? Here also you'll find something called permissions here. If you see here, there are more number of groups, right? Clear? So this is the place where the remaining child jobs are getting inherited. Okay. This is my organizations. So here also again same thing, users per particular one, whether you want to add all those things. We'll get in detail. There are few options like in pipelines and all. That time we'll see more detail. Just I'm showing you a few features what we have. Right.
So what are these groups, Sri?
Which one? These are the groups which will be inherited for the so many places, like your project level, your repository level, your pipeline level, many places which you are going to use these things. Basically, these are the pre-populated or predefined groups. So with the predefined permissions, you can see here, you cannot modify this because they are the administrators. So it is supposed to be allowed everything. For the members, you can see here, this guy and the service account of this. Let us go back to your project. I'll show you. Maybe open in. So in case if you want to add the users at the organization level, what we have seen, you modify whatever you want. So automatically those changes will get inherited into project level. If we go example, where is that option? Permissions. Permissions. So basically the flow, what I'm trying to say here is, first what you have, org level permission. It will inherit to the project level. Okay. From project, it will go to repo level. From repo, it can be applied to branch level. This is the hierarchy. There are multiple levels. That's what I'm trying to say here, right? So in case if you want to modify anything, right, within the branch again, so you can also control at the few version control tools will support your file level, right? Let's say if you have a Git, sometimes what happens, there will be a confidential, like all your security related information, right? Your credentials, everything, or keys, important keys, everything. So in those cases, you can uh, lock basically or the secure those particular files, which we are not supposed to expose to the other world. Okay. So basically the customization can be done at different levels, org level, project level, repo level, and branch level. Okay. That is what. So let us see this. I'll explain in detail. Okay. Managing Git branches in Azure repos. This is what we are checking, right? So how to lock a branch, all those things. There should be some table, branch permissions. Yeah. Okay. So a contributor, what he can do with the users who are part of the contributor load. So with these permissions, they can push new commits to the branch and lock the branch. That is what max they can do. They are the ones actually who are going to push the commits. Then there is one more role called edit policies, who can edit the branch policies. But we have seen, right, like in our branch policies. Yeah, edit basically. Bypass policies when completing pull request. So basically, some users can bypass the rules. Some users basically, right? If assume you have, go back to your branches. Here, you remember, right? Where we have done these branch policies. These are the rules basically. So So again, in this level, who can bypass this, who has to follow this, all those things can be managed at this group level, bypassing basically. Users with this permission are basically there will be a special cases, right? Where ideally what happens in the repo level, we are not supposed to allow any direct modifications, basically bypassing the rules because there is some reason why we are configuring the rules. So we have to follow that. Bypass policies when pushing, right? Users with this permission can push to a branch that has branch policies enabled. Okay. You remember, right? We have enabled the branch policies. So that time it was not allowing all those things. So for those kind of things also we can manage it, whether who can do that, who cannot do that, all those things. And force push. Uh, when will you get the force push? I think there was one scenario which we have seen, right? Where uh, history level or the if there are any changes, right? In that case, we have to use the -F option and push it, those things. Even that level, you can control it. So managing permissions, removal, locks, all those things. These are the different permissions which we have, right? So, so how it goes, users are there, right? Users will be added to groups. Other way, check. Group has uh, two things, right? One is permissions and you also have users. If permissions are assigned for the group, whatever it is, that will be reflected to the users, right? Don't get confused. It's simple. Basically, what I'm trying to say here
Yeah,
is,
yeah. If we apply anything to the users, it won't go to the groups.
right,
Yeah.
groups,
If
yeah, group level will manage. That's what I'm trying to say. Okay. This is how we can add these things. So now we know a few functions, all those things, right? So how the Git works. Let us see few Git workflows. Branching workflows, or what are the different branching types, right? So if we take now we know how to create a branch, right, and how to swap. But most of the time, what we have seen worked with this is a master branch, right? There will be a people will call it as master or main. It depends based on their terminology, right? Main branch or master branch. So if we take a project, right, there will be different strategies based on the requirements. So there are few scenarios or the situations points which you need to consider before deciding your branching strategies, right? Whether it is a master or future or right. So it is up to the even within the organization. There are so many ways people will manage based on the project size. There are so many things they will consider before deciding that. Okay, like how many branches I have to agree, how the branching strategy be, and what are the branching name strategies which you need to do, and what is the merge strategies, and how the pull request has to be created, and what how many reviewers are required, all those things. So has to be decided before your project work starts. Okay. So there are three common workflows. Trunk-based development. This is also called as feature branching. Okay. And Git flow branching. And third is forking workflow. We'll see in detail of each these things. What are these three things? Okay. So when we talk about trunk-based development, basically we need to follow that. What we are supposed to do for every feature, we need to create a feature branch first. Instead of directly making changes to the master or main branch, we should first create the feature branch, or maybe a feature branch or your enhancement or the bug fix, whichever it is, based on the requirement, right? So this is your feature branch, assume. Now, these dots are nothing but your commits. This is the pull request. Once the check-ins are done, commits are done, then the developer has to create a pull request. Why? To merge into the master branch. And he wants to share the code with others. Let's say this guy modified so many things and there are people who are waiting for it. So he can push it back to the remote branch. You hope you remember the scenario which we discussed, right? All features development should be taken place, whatever it is, right? Share a feature with others, basically, right? When he is done with the feature development, a pull request will take the code and so the reviewer basically, while creating the pull request, you need to add the reviewers. So that those reviewers, once the review is done, then that will get into merged basically to the target branch. Once that is done, then it will be deployed into the deployment branch. Okay. So this is what the few things. The master branch is the only way to release anything to production because it should be clean and neat. Anytime this will be tested version only should go and sit into the master branch because anytime any customer can come so your master branch should be dedicated to only for the production instances. The master branch should always be in a ready to release state, right? And the protect the master branch with branch policies, which is very, very important because only the DevOps or senior people only should have the access to master branch. Even we should not allow even the development team to do something. So the branch policies will play a major role. Any changes to the master branch flow through the pull request only, right? So that is the reason it is linked to here policy. If you enable the policy, obviously it will not allow you to modify, right? So you have to create a pull request. Why? Because any kind of change that is coming into the master branch has to go through with the review process and tag all releases in the master branch with the get tags. The tags are very, very important because uh, for future point of view, so and so date we have released to so and so customer. So based on the tags, so you can easily navigate to that, right? Basically, those are the advantages of branch, the master branch. These are the few things. Then again, you have to create the feature branch. Use features branches for all new features and bug fixes, right? And to manage long-running features branches, maybe the on enhancement you might be doing it. So this will continue for a month, right? So there will be some conditions which you need to apply for the feature branch. Okay. So maybe we can put conditions. There are some conditions which you can apply at the branch level. I'll explain at the time of deployments. There are different types of deployments, canary deployment, all those things, different types. So that time I'll explain the future level of conditions, how it will work. Okay. And changes from future branch to the master only through the pull request. Again, same rule. And name features already we have discussed, and pull request, review merchant, what all these things, right? This is what precisely what we have. If you remember one scenario we discussed somewhere.
The pull requests are to be done from feature to main branch only, right?
Right. Any basically between branch to branch, which is release or main branch or master branch. So that has to go through with the pull request. This is what we are actually we have tried it already. This is a common workflow. Okay. Trunk based. So what happens? See, let's say in other scenario, like there will be a master branch and the future branch. In between, there will create the development branches also, right? So based on the requirement, uh, in case first example, let's say developer first assume you have your master, then there will be a future branch, then there will be developer branches. right? So what happens? First, developer actually does his work in his here developer branch. This is developer branch, right? Developer 2. Then these developer branches will get merged into your feature branch because developer 1, developer 2, both are working for maybe feature 1, right? Once it is tested, this will go through with again some testing process. CI/CD pipelines can be enabled for this feature integration branch. If everything is satisfied, then only we will merge back to the master branch, because this has to be always protected, because this is directly linked to your production branch, production deployments. Okay, I'll show you here. But somewhere we have seen this, right? So where was that branching strategy? Not here. Where is that branching strategy? Somewhere we have seen, right? Here, right? So generally what happens, you have your master branch. Then there will be a development integration branch. From the development integration branch, the for let's say feature A, feature B, right? So A feature developers will check in into the development integration branch. Again, the feature B changes will get into the development integration branch. Here we can enable few pipelines. Once that it, it has to go through with some testing process. Once that is certified, then only it will go to the master branch. That is what. But the most popular one now, which has been used in the industry, is Git flow work branch. This one, Git flow branching. So what we'll do here, we'll create multiple branches. Okay, you try to understand this. There will be a master, there will be a hotfix, there will be a release branch, then development branch, then feature 1, feature 2, feature 3, and number of features. Okay, what are the benefits of following this branch? Basically, where is this?
Each and every guy can implement their own features and test, and then they can push it into main branch.
Right. So this is the scenario which we will practice also. Okay. So these are the advantages actually. Git flow is great for a release-based software workflow, right? In case if it is a robust framework, right? And this is also ideal for managing very large projects. If you have a small projects, an ideal way it is not recommended, until and unless if you have a robust framework with large projects, use this. And for hotfix, a concept also is there, something called hotfix, basically, right? So this is also very, very useful. So what is this flow? First, what we are going to do, first, there will be a master branch. We will create a development branch. This is development. The color indicates, you can see here, development. And from the development branch, I will create a feature branches, like feature 1. This is a feature branch. This is another feature branch. Okay. And when the feature is completed,
So we are generally extending the feature branch from the main branch and naming them as development, release, hotfix, and after that specific branches, we are creating another sub branch.
it is not going to be a sub branch. Okay. So what happens? You take a real-time scenario. Example, this is what the master branch, which the DevOps engineer is going to maintain. Basically, this is a release branch. Okay. Now, if I allow a development team to do the changes directly into this, what happens? There is a high possibility of checking in untested code. Okay. So what happens? Which is supposed to be clean and neat at any point in time, my master and release branch is got corrupted with the untested code, which is not at all recommended and which is not safe. That is the reason we will always have a development branch parallel to the master branch. Okay. Again, in the development branch, assume there are multiple developers. There are 10 developers. Maybe 5 will be working for feature A and another 5 will be working on feature B. Again, I don't want to create a single branch in the direct development branch. Feature A changes and feature B changes will get merged into this point. So what happens? Assume you have an issue. Then it will take more time to identify who has created this issue, whether this feature or this feature or this feature. There will be a number of scenarios. I'm talking about in real-time scenario, there will be hundreds of developers also, right? In that case, it is always recommended to have a separate feature branch, right? Then have it tested there itself. If it is certified and it is satisfied with the expectations, then only push it back to your development branch. Okay. From the development branch, we will release it, maybe internal releases. If internal release is okay, then put it back to your master branch. Basically, what happens, the deployment also will come into the picture. Assume this is the feature. This feature got merged here, and this feature is also got merged, and we have reached the end of sprint. Assume this is sprint 1, this is sprint 2, or sprint A, sprint B, team A, team B. So basically, the sprint level also we can create this. So once the sprint is completed, this will push it back to merge it back to
Main branch, main branches.
right, your development branches. So let's say you have multiple sprints here. Then we will merge it back to the release branch. Something called release branches also will maintain. This is the practice which is followed, right? Now the code of the development branches will go into the release branch. So all our pipelines or CI/CDs basically, right? QA is going to perform test here. UAT basically, UAT user acceptance testing, right? UAT will happen here. When QA is approved, this UAT, then we will merge it into the master branch. So how many places here testing will happen? Here testing will happen. Here testing will happen. After so many testings, so it will go to the master branch. A recommendation of code is development code to dev environment, release code to QA plus UAT environment, and master to production. This is the reason we will maintain multiple branches here. Okay.
Got it.
This is what a Git flow work, right? A developer branch is created from the master. A release branch is created from the developer. A feature branch, same. This workflow is explained here. Okay. Then what is this hotfix branch? Sometimes what happens, you will release it to the customer. There will be a showstopper. And what happens? If I go through with this entire process, that may take a month, following in sprint, all those things. But customer cannot wait for those so long, right? So that is the reason we'll call it as hotfix. So we'll derive, assume version 0.1 was given to the customer. The point where we have given it to the customer, from the same point, we'll create a hotfix branch. The fix is given here. Immediately we'll push it back to the master. We'll call it as V02. This is not going to be a major change. If it is a major change, again, the process has to go through. The hotfix is just to identify, let's say you need more logs, right? Then just give that printf statements and deploy so that you'll get a more logs. So those are the hotfix branches. Now, once the hotfix branch is merged here, you have to make sure that the fix, whatever has been given directly to the customer, has to come back to the developer branch. What happens if you don't do this? Over a period of time, you will merge it back, this particular change, assume this, and all, into master branch. Now what happens? The change what has been done here will be overwritten with these changes. That is the reason we should always make sure the hotfix changes should come back to the development branch as well. Okay.
Okay, जी.
Now, what is one more? We have one more forking branch workflow, right? That is
Working.
what, right?
Yeah, picking up a copy of feature or main branch and keeping it on our local.
Right. What is this forking branch? Basically, I have mentioned here. Forking branch workflow gives a developer their own server-side repository. Now, what happens if we see? So, what we have seen, we have just working with one repository, right? This is, you can always create a new repository here or import repositories. Okay. So always create this new repositories, multiple repositories. Basically, for the same project, under the same DevOps project, you can create multiple repos. What happens? Uh, Sometimes what happens? Uh, I want someone else to work on my project, but you should have your own branching policies. You should have your own. Basically, you should have a full control. But I don't. At the same time, I don't want to give control for my actual branch, right? I don't want to give permissions or the access, complete access to my repository. So
We'll give him
that
the metadata entire folder kind of thing to him.
basically the same environment will be given it to the your name example. So that's when you'll have full control on your branch. So you will be developing your changes for more than a month. Then it will come back those changes into my actual repository again through some pull request. Okay. Forking branch. Okay, let me show you so that this over this thing here. Here, fork. So we would log into this, my repository, wherever it is. Then I will fork into whatever the name, repository name you can give, hello world dot or whatever the name you want. So only the default branch or master or all the branches. Assume I have multiple branches now. I have F7, all those things. Okay. So just fork it. This is a completely a new forked branch, right? You have full control on this. So what are the advantages? Is simple. Forking branch will give every developer their own server-side repository. Now, the developer who has created, he will have complete control on this, right? Most often seen in public open source projects. When do you need this? This is mainly used for the public open source projects because I really don't know who is contributing to my project. So that is where I don't want to give any access, any control on my actual repository. Let them do whatever they want in their forked branch basically, right? So where they have full control. Okay. Let us do one thing. This project, right? Project settings. For you, where is that option? There is supposed to be, they removed it here. I was checking whether it is a public project. Okay, not an issue. Here. This is what. Okay, assume if I go here, generally, if you use the forking option, it will ask. Okay, but if you log in with the fork option, basically, once you log in, basically, because I am the user for one, right? I cannot demonstrate. If you log in, basically, right? And if I give this to you, where is this? Clone. Okay, you can directly fork this particular repository. So you can fork it. Once you fork it, so you can completely work on your project. Once you are done with this, once that is done, go to your branches. Okay, create a pull request. Nothing is there. Create a new pull request. Here, you see here, this is the forked branch, if you remember. Hello world demo followed by the username. So you can select for where you want to do this. Select as your master. You have this from this to this, wherever it is. Example, in this forked copy, master branch to hello world demo repository master branch. Create a pull request. There are no changes. In case if there are changes, it will allow you to create a pull request. Okay. Eventually, the branch which was forked, right, a repository which was forked from that point to another point, mainly used for the public projects. Okay, these are the advantages of these things. I've given steps here. Then another thing which you need to whether you want to work with multiple repository or single repository, mono project or multi-repository. So in which scenario is better, right? In case if you have a project where your solution have, let example, if you take a .NET developer, your solution might have multiple projects. That's what I assumed you, right? You have a choice of working with all these projects, or you want to maintain a single repository, individual repositories for every project, or if you want to maintain a single repo for multiple projects, basically the solution level or a project level, right? If you remember, a solution can have multiple projects. So we can maintain repository at the solution level, or we can maintain repository at the project level. So again, depends on the requirement. So if you use mono, clear ownership, better scale, and narrow scopes, right? In case if it is multiple, so better developer testing, reduce code complexity, effective code reviews, sharing of common components, easy relation. If your requirement is, uh, I mean, if a project requires these things, go with this. Otherwise, go with this. Okay. This is actually a critical work of a DevOps engineer, uh, because as a DevOps engineer, you might have to suggest that which is the better option. So this is the recommended way of doing that. So maybe theoretically it is like this. When we do the pipelines, you will understand better. All these things we will do practically. Okay. We'll create developer features, we'll merge it back to so on. So then again, we'll put it to the release. We'll connect these things into different staging areas like development staging area, QA staging area, pre-production or production. We'll create the live environments. Don't worry. Then you will understand better. Okay. That is what we are going to cover in pipelines. Otherwise, yes, this is what the branching workflows. Okay.
Sir, a small doubt.
Yes.
Do we have the concept of release-based branching?
Released based branch.
Yes, because I read about that as well. Along with trunk-based feature and fork, we have release-based.
That's what the the released based branch also will cover here, right? This scenario. That is the reason
yes,
I'm
yes,
not
understood that. Understood that.
expressing.
Though it was, yeah, it was specifically mentioned there, so I was just a bit.
You can split it,
Confused.
no issues.
Okay, okay.
That's what
So
it is. Mostly
the
what happens, based on the project requirement, it things will vary here and there. But ideally, this is the best practice which is recommended.
demand narration.
Okay. We'll do next session. We'll see Git hooks. These are also important. I think somebody was asking whether we are going to cover hooks, right? So I'll show you a small hooks, how to create all those things. Okay.
Okay, sir.
Given the simple hook, not major thing. In case if you want to, uh, let's say, validate few conditions, cover the 5 minutes it will take. Okay. So what are the hooks basically, right? Hooks are required for certain validations. Okay. So if we take any our repositories, right? This is what our project. So go to inside this .git folder. Why do you need hook basically? So if you take any project, right, there will be a certain guidelines which we need to follow. Example, you are not supposed to hard code the credentials. That is one basic thing, right? Now assume unknowingly, or maybe the freshers or interns might have done that. How can we prevent that? There will be thousands of files, lakhs of files in a virtual source. So for an engineer, it is really difficult to go and check all these things manually. That's where we can write hooks. That is one scenario. Another scenario, like pre-commit hooks or post-commit hooks. Before committing, if you want to validate something, let's say my or any code which is committing or checking in into the repository version control system has to be like this, A, B, C, D. You can define your rules. Maybe you have to the length or some conditions based on your project requirement. Okay. So before committing, what happens based on these conditions, it will validate before committing itself. If it is not satisfying the rules which have been defined, then it will throw an error saying that, boss, this is supposed to be like this, but it is not meeting the expectations. Please go and correct this, then come back and commit it. It will reject straight away. Then something else like after commit, post commit, there will be few things. Post commit, right? Let's say as soon as commit happens, I want the commit information. Let's say the number of files, the code details, the author details, branch details, all those things have to be notified for certain group. So I can add a post commit hook for that. right? Like this, there are so many examples. So this is the advantage of adding pre-commit and post-commit. In case if you want to use those things, see, they have already sample commits will be there, right? Hooks basically. So remove that sample and enable it. So then automatically it will get enabled. Any language you can write. Can whichever language you are comfortable. If you are comfortable in Shell, you can write. If you are comfortable in Python, it will accept all the languages. There is no restriction on the language. Only matters here is the logic. Or you want to, let's say, for every commit, in the commit message, hyphen m we are giving, right? I don't want to mention my branch name every time. So I want to include that particular branch name in my commit message. So you can write a pre-commit hook for that. Okay. Basically collect the information and display that. So simple logics, whichever you want based on your requirement, you can write this and just enable it. That will automatically work. So that is the advantage of hooks. So you can just enable. So where will it be? It will be under your .git folder and hooks, under hooks folder. So there are so many examples. The sample code is available here. 99% only a one person will be working in DevOps team. May not be the job of most of the DevOps engineers, right? And most of the times the organization level, your global level hooks will come from your IT or whoever is managing those, right? So nothing to worry about much on the hooks part. Just for idea purpose, knowledge purpose, I just shared this information. Okay. Any doubt?